next page, page 187, question 21, part 1. So we're asked about find the value of n element n, so n element natural numbers. This is going to be important. If they give you a restriction like that in the exam, write it down next to where you're going to put your final answer. So to mimic that, I'm going to put down ANS, n is equal to, and I'm going to have n element natural numbers. That's what you want to put down at the bottom of your answer box in an exam, particularly when they give you a restriction like that. This is almost always going to be important. Now, let's write down what they've given us. We have n choose 2 is equal to 10. So n and 2 is our OR. So let's remind ourselves of our formula. This is what I was talking about at the end of the last video. We have n choose OR is equal to n factorial all over OR factorial, n minus OR factorial. And we worked out the last time. Well, actually, let's write this out fully, pretending that we don't remember our formula in the exam, because we might not. Let's write this out the long way. So OR is going to be 2, so I'll have n choose 2 is going to be n factorial all over 2 factorial on n minus 2 factorial. So we have that already. We know how to write that. And now let's expand these two out a little bit, or expand all of it out actually. N on n minus 1. We know what our factorial means. On down to minus 2, n minus 3, on down to 1. That's what n factorial means. We've already worked through that. Here we have 2 factorial, which is 2 by 1, on n minus 2, on n minus 3, on all the way down to 1. Now if we look at our problem here, we have n minus 2 by n minus 1 all the way down to 1, and we have n minus 2 by n minus 3 all the way down to 1. So I have a common factor of all of this down to 1. So I can divide out by my common factor, and I'm going to be left with this business here. So I have n on n minus 1 all over 2 by 1. And I'm told in the question that that is equal to 10. And in an exam, I would actually advise you to have written that down as you were going so you didn't forget about it. So I now have this, and we possibly can recognize what's going to happen here. I'm going to get a quadratic. So I multiply both sides by 2 to get rid of my fraction, or 2 by 1 if you want. And I'm going to end up with n squared minus n is equal to 20. This is a quadratic. Bring everything to one side, or minus 20 from both sides if you prefer. And I get n squared minus n minus 20 is equal to 0. However, as you factorize out your quadratics, you will end up with n minus 5 by n plus 4 is equal to 0. So n minus 5 is equal to 0. N plus 4 is equal to 0. Rearranging, we get n is equal to 5, or n is equal to minus 4. And now we can see the significance of n element natural numbers. We don't include this answer here because n is an element of n. So n is equal to 5 is the only answer we accept. Now, those are all the questions I'm going to go through. I want to make a quick note of the English in 2 other questions, but I don't want to take up your time doing them. There's some of the questions that you're being given for homework. So we have question 11, and if we look to part 2 of that question, you can read this in your own time. It says each subset contains at least one vowel. At least one is a key phrase in probability. At least one. So what does that mean? We translate it into what it's going to mean in practice. It could mean one of something, or it could mean 2 or 3 or 4 or so on. It could also mean the total number of ways of doing something minus none of the thing we're looking at. So in the example, we could have 1 or 2 vowels, or we could find out the total number of arrangements possible and subtract away the number of ways that you could have no vowels. So this is going to be an extremely important key phrase in probability as we move forward. So at least one of something could mean one of it, or 2 of it, or 3 of it, or 4 of it, or so on, or it could mean the total number of possible arrangements minus none of this thing happening. So that's question 11 part 2, a hint for question 11 part 2. And the other piece of language I wanted to talk to you about was question 15 part 3, another question you have for the homework. And it's simply to remind you that it's like the last question we did the other day. If neither Mr. nor Miss Jones can be included in the subcommittee, that would be the same as the total minus both of them being included. So neither being included would be the same as the total minus both being included. And again, this is a very closely connected idea to this, because we're dealing with opposites of situations. So neither would be equal to the total number of ways of arranging something minus both of them being involved. So that is all we need for now.